Okay. How is the recording? So today we'll start a new topic. Actually, it's the continuation of previous one. Today is our 10th lecture. So today we'll start from another topic. This will be Gregory Newton backward interpolation. Okay, Gregory Newton backward interpolation formula. So I think we should not go for the details derivation, because the derivation procedure is almost same. First we will take an function y is equal to f of x, such a common function, and in which the different values of x and y, like y0 to yn corresponding x0 to xn. Okay, so for this function we should start in the polynomial form as previous. Y is equal to yx is equal to a0 plus a1 x minus xn. Okay, last class I discussed that we should start from the backward side, that means in forward interpolation, and our target is to interpolate any values within the forward range. And similarly for the backward interpolation, we will use the values, or the interpolate the values in the backward range. So while deriving the formula, we also should keep in mind that we should incorporate the backward parameters. That means in previous formula we just write x minus x0, then x minus x0 multiplied by x1, and in this case we will write just in reverse order, that means x minus xn multiplied by x minus xn minus 1, and plus a3 x minus xn n minus 1 x minus x n minus 2. And throughout this equation, ultimately both equations are same, just writing is different, and the resulting equation is same. So in this case also we put x is equal to reverse order, that means xn and then xn minus 1 x n minus 2 up to x0 to get successively to find the values of this coefficient a0, a1, a2. That means in this case there will be some sense. Suppose for the first times if we put x is equal to xn corresponding yn, that means you will get the value of a0 is equal to yn. Okay, and in the same manner you will find the value of a1. The value of a1 yields you to like this: yn minus 1 divided by xn minus 1. So we know xn minus 1, that means two immediate steps. Okay, two immediate values of x, and the difference is as usual h. And yn minus 1, it will gives you the value of nabla yn, that means first backward difference. Okay, this is the first backward difference. And similarly, when we go for a2, I am not going for the details calculation. It simply give you these types of result after simplification: nabla square yn 2 factorial h square. That means very similar to forward difference formulas, where in forward difference this was the first forward, these are the first forward difference of y0, that means initial item, initial value of x, and this was the del square y0. Okay, but in this case these are the just coming from the backward side, and the last value, that means nth value. Nth value means the last value, last couple of data set in your given table. Okay, so similarly a3 will be 1 by 3 factorial h cube, third backward difference of nth order. So from this you will get the values of yx. This will be yn plus 1 by h yn x minus xn plus by 2 factorial ac square yn x minus xn x minus xn minus 1, and so on. So again here you will put let x minus xn, in this case let x minus xn by h, this parameter is equal to p, so that x is equal to xn plus ph. So you put this value x minus xn, you put this value in this equation, you will get the values of yp. This will be yn plus p yn plus p into p plus 1 2 factorial yn plus p into p plus 1 p plus 2 divided by 3 factorial yn. Again there is a harmony in this equation, so you can simply remember this equation, and the last terms will be p plus 1 p plus 2 dot dot p plus n minus 1 divided by n factorial multiply yn. Okay, that means the first term is p, then p into p plus 1 by 2 factorial, and next one 3 factorial p plus 1, and next term p plus 2, and so on. So in forward difference the formula was like this: y0, that means initial term, p into del y0, then p into p minus 1 del square y0 2 factorial, and p minus 2 p minus 1 p minus 2, that means p minus 1 p minus 2, and so on. And in the backward difference formula it becomes p plus 1 p plus 2, and so on. So these are the basic difference. And another difference in the formula, that while the forward difference, while you will calculate p, this will be x minus x0 by h, but in backward difference it will be x minus xn divided by h. Okay, so remember this one also. So this is the very easy formula as before to memorize. Now we can go for an workout example. Also, by using these equations, another technique, say by if you use these equations for other purpose, like you need to know the equation for a given data set. Okay, not necessary to always by using interpolation formulas we can only find the intermediate values of a given function or of a given range. We can also find the values of for an independent and in this equation yn this is known. Okay, h this is also known. Del is if you have a given data set you can find all these from the difference table. Okay, xn this is also the known value for a given xn minus 1, these are also known value. So if you have a finite number of data set, that means 3 4 or 5 number of data set, that means if you have a 4 number of data set, there may be probably 4 to 5th term in this equation. So only the unknown is x, and in left hand side only the unknown is y. So you can simply you find a polynomial equation. Okay, polynomial equation are representing y a function of x. Okay, here maybe fourth order fifth order polynomial equation. So both things can be done. Say you can simply you find a value for an unknown, or you simply calculate the intermediate values, or you can find the basic equation, that means an interpolation equation, common equation for the given data set. So these things can also be done. So let's an example. I will throw this polynomial portion for your homework. Find a polynomial. Find a polynomial which takes the following values. Y of x, that means corresponding values. 1 is 3, 3, 4, 14, 5, 19, 7, 9, 11, corresponding 21, 23, and 28. Okay, this is the set, and hence compute yx at x is equal to 2 and 12. Okay, this is a comprehensive problems, few parts. First one, you need to find a polynomial. This is one part using these values which follow this data series. Also compute the yx, that means y value at x is equal to 2 and 12. Okay, two values. That means if x is equal to 12, okay, x is equal to 12 is actually beyond your data set. That means extrapolation is also part of interpolation. So is a specific type of interpolation when the data, the prediction is goes beyond your data set. So for as for the 2, x is equal to 2, this is in the initial zone of your data set, that means in here. So you should use here the forward interpolation formula, and similarly for x is equal to 12, you should use the backward interpolation, Newton's backward interpolation formula. That means you should go for here. Okay, in this range, data is in this range. So uh, forward interpolation, I think this portion is well known to you as last class you can complete. So our first task for such types of problems, our main task is to formulate the difference table. The first task is the difference table. So form a difference table. So as I only show you the backward portion, that means I skipping the forward interpolations because it's already known to you. So only the backward portion. So this will denote as backward interpolation del yx. Sorry, I can write it as for backward. I can write it as yx.
y এর ফাংশনটা কি দুনো মেথডেই সেম আসবে?
Method, yes, I think should be same, or sometimes there may be difference. It's actually depends on your data. That means for real life data or field data, it is recommended to use the formula based on your problems, but the difference table is same. There is no change in difference table. That means I write is nabla yx, this is also del y0. Okay, same thing. There is no change actually. So if you ask to solve such types of integrated problems, there where the backward interpolation and forward interpolations both are required. So you guys simply can do one table. Okay, one difference table, because the numerical values are same. So you should not repeat the same tables for 2 times. And the technique is for this is actually, this is nothing but del square y0. Similarly, this is nothing but this is y0. So now both things are actually same because the numerical values are same. So let's start. 1, 3, 5, 7, 9 and 11. So the difference 28 minus 23, this is 5, this is 2, this is also 2. For 19 14, so this is 5, and 14 3, so this is 11. And the next difference, second order difference, 5 2, so this is 3, 2 2, this is 0, 2 minus 5, that means minus 3, 5 minus 11, that means minus 6, and 3 minus 0, so this is 0, 0 minus minus 3, so this is also 3, and minus 3 minus 6, that means plus 3. So these calculations you need to be careful because you always
3 স্যার 3 minus 0 3 হবে না এটা?
3 minus 0, oh sorry, this is 3, this is 3, and here all of these terms are 0. So actually these problems goes up to this, okay. But as these two terms are 0, so we not need to go for this one. In fact, as this one is 0, so this will also be uh, cancelled. So look at this equation, the backward interpolation equation. Which values you required? Yn, that means the last values. That means you need to choose these values, okay. And alternatively, for forward interpolation, we choose these values. Clear? So that's the same difference table. For when you predict for x is equal to 2, you will use the forward interpolation formula, and from the table you will choose these you will choose simply these coefficients, okay. And parallelly, when you go for backward interpolation, same things, just use this lower portion of the table, that means lower diagonal, these values. So you once you get these different tables successfully, the next step is to so in this problem we will also for x is equal to 12, okay. So using we should use Newton's backward interpolation. So the formula was, if I copy this one, so this is your formula, and here we need the value of p, and the value of p is equal to x minus x n divided by 2, okay. Here xn is equal to 11, so x is equal to 12, so 12 minus 11 by 2, this will give you p is equal to 0.5. Clear? So p is equal to 0.5 yp, this yn is equal to the last term 28 plus p, if it is 0.5 multiplied by del yn, that means 5 plus 0.5 into 0.5 plus 1 divided by 2 factorial multiplied by this is nabla square yn, that means 3. And last term 0.5 multiplied by 0.5 plus 1, 0.5 plus 2 divided by 3 factorial multiplied by third term means this is also 3, so multiplied by 3 plus 0 plus 0. Actually the next two coefficient from this table is 0, these two are 0, so you not need to write it's unnecessary. There's already our yields to the zero values. So this is your calculation. You can simply calculate is 28 plus 2.5 plus I think 2 factorial means 2. That means this will give you 0.5 multiplied by 1.5 multiplied by 3 divided by 2. Okay, plus 1. So after completing this, you will get the value of y12. That means y value corresponding to 12. This will be 32.5625, something like this. Okay, and another portion is the find the polynomial. So to find the polynomial, you simply follow any one equation. That means Newton's forward interpolation or backward interpolation. Both will gives you the same equation. For the equation, you will simply do one thing. You will simply take this equation, the immediate step. That means this step. That means x minus xn, x minus xn, x minus xn minus 1, like this. So I am just starting y is equal to yn means the last terms, yn means 28. Okay, plus come to this equation. Where is it? Nabla yn x minus xn, first term, 1 by h nabla yn x minus xn. So 1 by h, that means here h is equal to 2. Okay, from this table you may find x is equal to 1357. That means h is equal to 2 multiplied by the first term, simply nabla yn. That means nabla yn value is 5. Last one, this one 5 multiplied by x minus xn, the last term. The last term of this table is xn 11. This will give you x minus 11 plus next term 1 by 3 factorial. This is 2 factorial and 1 by 3 factorial. Sorry, I made a mistake. 1 by h. Okay. And for this 2 factorial ac square. That means h means 2. That means 2 square multiplied by next coefficient is 3 multiplied by x minus 11. That means xn, x minus xn minus 1. That means next one. That means xn minus 1 means 23. Okay, 23. Sorry, not this. 23, not corresponding value 9. That means xn minus 1 is 9. And next, plus 1 by 3 factorial h cube. H cube means here h is 2, so 2 cube multiplied by coefficient. The coefficient is next coefficient, this is 3, so you put it 3 multiplied by x minus 11, x minus 9, and next term x minus 7. Okay, just this one, x minus 7. So again for these steps also, the next terms will be 0, as the coefficients from these tables are 0. So you can simply here find that from the right hand side only the unknown one value is the x. That means, and you will multiply these two and these two, and these portions are simply numerical value. These are the numerical values. So this is very easy to calculate and simplification. I think it will take 2 or 3 steps for the numerical simplification. And after simplifying this equation, and you will find the precise equation y is equal to in this form. After simplification you will find 1 by 16 x cube minus 21 x square plus 159 x minus 91. So this is your desired equation. Same things and the same equation can be developed from the forward interpolation formula, and I think you will get the same equation. So this is the some brief summary of the Gregory-Newton backward interpolation formula. So if you have any question relevant to this lecture, the floor is now open. But I think both methods are same, and the successive upcoming problems are also the same types. You just need to find out a technique to memorize the equation and the difference table is as well as previous same, and only the difference will be in the calculations and steps, and some techniques you need to, and some decisions you sometimes may need to take, like independently you will given a problem. This is the main key points of these interpolation methods. You will given a function, but you will ask to solve this problem. Okay, I will just for this one I asked you to solve this problem, so I didn't mention any method. You can choose anyone, but you need to keep in mind which one is best suitable for which types of problem. Okay, so this is an important thing. Problems, anyone can solve the problem, but the decision makings, okay, I chose these methods for these specific types of problems. What's the logic, or what's the background? So you should have some numerical background. That means while solving any methods or introducing any new methods, we also always discuss the advantages, disadvantages, and suitability of the methods as well. So while solving any problems independently, you choose many one, but you have to understand and you have to choose the right one. This is the decision making. Okay. So now if you have any question, you can, the floor is open.
যে কোনো ফর্মুলা ইউজ করে আমরা পলিনোমিয়াল বানানোর পরে তো যে কোনো ভ্যালু ইউজ ইন্টারপোলেট করতে পারতেছি।
হ্যাঁ, পলিনোমিয়াল বানাইলে ইন্টারপোলেট যে কোনো ভ্যালু করতে পারবে। হ্যাঁ, সেটা ঠিক আছে, কিন্তু এই প্রবলেমের ক্ষেত্রে পলিনোমিয়ালটা করা খুবই ইজি হয়েছে। ওকে, এই ক্ষেত্রে পলিনোমিয়ালটা করা ইজি হয়েছে, তার কারণ হচ্ছে তোমার ভ্যালুগুলো খুবই সিম্পলিফাইড। হ্যাঁ, যখন তোমার রিয়েল লাইফ ডাটা আসবে এটা এতটা সিম্পলিফাইড হবে না। সো এটা তোমাদের জন্য একটু ডিফিকাল্ট হবে। তো সেক্ষেত্রে সবসময়, আর এই ক্ষেত্রে দেখো যে ক্যালকুলেশন তোমার অলরেডি কি হয়েছে, 3টা, তাই না? আমরা যেটা দেখলাম যে তোমার কি বলে, এই যে টেবলে খেয়াল করো, অনলি ডেল কিউব মানে থার্ড ডিফারেন্স পর্যন্ত আসছে, এরপরে কি হয়ে গেছে তোমার 0 হয়ে গেছে। সো এই ক্ষেত্রে তোমার ক্যালকুলেশনটা অনেক ইজি হয়ে গেছে, কিন্তু যদি 5টা অর্ডার 5th অর্ডার পর্যন্ত থাকতো, দ্যাট মিনস এখানে x টু দি পাওয়ার এই ইকুয়েশন x টু দি পাওয়ার 5 পর্যন্ত আসছে, দ্যাট মিনস এই পোরশনে আরো অনেকগুলা মাল্টিপ্লিকেশন থাকতো। সো এতগুলা ক্যালকুলেশন করা এটা একটু অনেক জটিল। তো সেই জন্য শুধুমাত্র যখনই পলিনোমিয়াল ইকুয়েশন বের করতে চাইবে তখন হচ্ছে তোমাকে এই কাজগুলো করতে হবে, আদারওয়াইজ দরকার নেই। ওকে,
স্যার যদি এই ম্যাথটাতে পলিনোমিয়াল আগে বের করে তারপরে x টু দি পাওয়ার মানে x ইকুয়াল টু 9 আর 12 বসাই, তাহলে তো রেজাল্ট চলে আসছে।
হ্যাঁ, রেজাল্ট অলমোস্ট সেম আসবে, রেজাল্ট সেমই আসবে। বাট কিছু
তাহলে কি
রিয়েল লাইফ
স্যার আমরা
প্রবলেমের
এগুলো
ক্ষেত্রে
করবো?
ফরওয়ার্ড ব্যাকওয়ার্ডটা মেনটেন করা জরুরি হয়, যেগুলো হচ্ছে তোমার মানে কোনো রিদম মেনটেন করে চলে না, এরকম কিছু ন্যাচারাল ফাংশন আছে, দেন টাইম, টেম্পারেচার, তারপরে কোনো মেশিনের পারফরমেন্স বা এই টাইপের। তো সেক্ষেত্রে এরর কমানোর জন্য আমরা সবসময় আহ, প্রথম দিকের ডাটার জন্য ফরওয়ার্ড ইন্টারপোলেশন এবং লাস্ট দিকের ডাটার জন্য ব্যাকওয়ার্ড ইন্টারপোলেশনটা ইউজ করব। ওকে, সো আই থিঙ্ক মোটামুটি আজকের ক্লাস সবার ক্লিয়ার। ওকে, তো আমি তোমাদের লাস্ট লেকচার গুলো আপলোড করে দিচ্ছি, আজকেরটা এখনই আপলোড করে দিব। তোমরা যারা মিস করছো তারা একটু হচ্ছে দেখে নিবা। আজকে এখন কতজন আছো? 109, দ্যাট মিনস অনেকজনই মিসিং। সো একটুখানি তোমরা ইয়ে করে নিবা, এটা অ্যাডজাস্ট করে নিবা, যাতে সবাইকে ইনফর্ম করে দিবা। তো ঠিক আছে, আজকে ক্লাস এইখানেই ক্লোজ করতেছি। ভালো থাকবো সবাই। ওকে।